I'm Wendy. I'm going to explain about variable selection today. When you are considering p-many explanatory variables, you want to select some explanatory variables which are economically effective, right? So we have three methods to select explanatory variables. Before I explain variable selection, I'd like to review a little about partial f again, because I told you in the multiple regression model, beta j equal to 0 to test problem, we use t value, okay? Let's see how to use t value. Here, this is the example. Y equal to beta 0, beta 1, x1, beta 2, x2, beta 3, x3, right? Three explanatory variables in the model, and we get this result. Then h0, for example, beta 2, this one, beta 2 equal to 0 or not. In that case, p-value is 0.001. So it is effective. We have to use x2 as an explanatory variable. Where we get this one, p-value? If you use statistical software with computer, the results shows two tables. This one is estimated coefficient, and another one is ANOVA table. ANOVA table is not here anyway. So from here, x2 0.8294, and the p-value is 0.001. This is a p-value with what? With t. So I'm worried about somebody will confuse this kind of thing. Where is it? Example? No. Oh, this is to where? Here. Okay? Here, in this part, section 13, the test statistic is partial f, but t squared with degrees of freedom n minus 1 minus p equal to f with degrees of freedom 1 and n minus 1 minus p, theoretically. So we may see easily this kind of results, but I skipped it. And I skipped this one, this part, last time because of some difficulty, okay? So you don't have to worry about why sometimes use t, sometimes use partial f in order to test each parameter, okay, equal to 0. So you don't worry about sometimes you use t, and here we use partial f because of this relationship. So you don't have to be controversial. Okay, let's see. Variable selection. Variable selection refers to the problem of deciding which explanatory variables among p variables considered in regression analysis should be used. Ideally, y should be well explained with as few explanatory variables as possible. You don't have too many explanatory variables. Some effective explanatory selected as possible, because this is impossible without a computer. You don't have to solve this problem with the hands. Variable selection is typically performed using statistical software packages. There are three methods for variable selection. Backward elimination. This model involves initially including all p explanatory variables in the model, then gradually removing the least significant. Okay, least significant means least meaningful explanatory variables. The least significant variable is the one with the smallest partial f value, okay, indicating it is the least important. The process is repeated repeated similarly for the next variable to be removed, continuing until no more variables needed to be eliminated. In this method, once a variable has been excluded, it is and it is not reselected in the future. Next step. Okay? One variable has been excluded, then that's it. Well, I mean, it is not reselected. Okay, forward selection. Backward elimination, it is the different opposite way. The forward selection method is the opposite of backward elimination. It begins by selecting the most important explanatory variable first, the one with the largest or most significant partial f value among the p variables. After that, it continues by selecting the next most important variable from the remaining variables, which are already included in the model. Okay? This process is repeated until there are no more significant variables to add. In this method, also, once a variable has been selected, it is not excluded in subsequent steps. So one is selected, that's it. Okay? However, this comment important because there may be some correlation among the explanatory variables under consideration. The above two methods may not always be appropriate. In other words, the importance of a variable that has been already been selected may diminish when a new explanatory variable is added. You understand? Because because there may be some correlation among explanatory variables. The importance of a variable that has been already been selected may diminish when another explanatory variable is added. Therefore, it is common and preferable to use stepwise selection method. Okay, so you understand these two logics, then you may this one stepwise selection method is the best. So you may you just take this method in order to variable selection among your explanatory variables. This method is based on forward selection, but includes a step of backward elimination. Some complicated, but the computer package will work. Specifically, it selects the explanatory variable with the largest partial f value into the model. Largest partial f value will be what? Significant. P value is very small. So you may take the largest partial f value, what? Variable, explanatory variable into the model. And if the next selected variable makes, this is a process of a forward selection, next selected variable makes some existing explanatory variables unnecessary. You understand that? The next selected variable makes some existing explanatory variables unnecessary. Those variables are eliminated from the model using backward elimination. Okay, you consider x1, x2, x3, x4. Okay, for explanatory variable, you select x2 first because the partial f value is the largest and the p value is very small. So next step, you select x4. Okay, x4 is the largest. X4 has the largest partial f value, and it is also significant, small p value. Okay, so you select x4 by what? Forward selection method. But here, in this case, you check the existence of x2. x2 is necessary or not when working with x4. Sometimes x2 will be eliminated. But forward selection, I told you, if x2 is selected once, then it stays in the model forever. But it is not reasonable. Why? There exists correlation between x2 and x4. That's what I mean here. Okay? Those variables are eliminated from the model using backward. Now you consider that this method consider backward elimination. This process continues until there are no more variables to add or remove, resulting in a method with an optimal set of explanatory variables. So you better use stepwise selection method when you use statistical software package. Okay, that's it. That's it today. I have some sections left to finish this lecture. Okay, thank you. Bye.